I want to show you more examples of simplifying expressions using different exponent rules. So I'm just going to go through 4 of the questions on your final exam review. So we have a few ways to think through these. Some of you may have felt more comfortable memorizing rules from class, and some of you may have felt more comfortable expanding. So I'm going to show you how to expand so that in case you forget any of these, you're able to use that as a fallback. So on the first one, this entire quantity, negative 4y squared x cubed, is being raised to the 4th power. So that essentially means that you're doing negative 4y squared x cubed times itself so that you have 4 of them multiplied together. Okay. Now, everything here is being multiplied. Yeah, I have the parentheses there, but essentially everything is being multiplied. So you can do all the negative 4's being multiplied together first, and then all of the y squareds being multiplied together, and then all of the x cubes being multiplied together. You're allowed to rearrange that. That's a property of multiplication. So really what we're doing is negative 4 to the 4th power. And negative 4 to the 4th power is 256. Then we're doing y squared to the 4th power. And a power to a power, you multiply the exponents. But if we forgot that, remember y squared is y times y. So another y squared, another y squared, another y squared. You have 8 of them total. So we would have y to the 8th. And then x cubed to the 4th power is going to be x to the 12th. So our final answer here is 256 y to the 8th, x to the 12th. On the next one, I'm going to rewrite it over here. Y to the negative 2nd power times x cubed. Well, we know we're not allowed to have a negative exponent. And the way that we handle that is we think of this as 1 over y to the positive 2nd power times x cubed. In x cubed, that's just like being over 1, and when we multiply fractions, we multiply across. 1 times x cubed is x cubed. Y squared times 1 is y squared. So this is your final answer. The x cubed didn't have to move because nothing was wrong with it. It got to stay on top. Below, 21 x to the 5th, y to the 9th, over 12x squared, y to the 12th. Or actually, I'm sorry, that's a 13, so y to the 13th. We're just going to deal with one piece at a time. So first, I'm going to deal with the coefficients, the 21 over 12, and we're just going to reduce that. 21 over 12, 3 goes into both of those. It reduces to be 7/4. Now, x to the 5th over x squared, you have a couple of ways of thinking of this. If you prefer, picture it expanded out. X to the 5th is 5 x's multiplied together. X squared is 2, so I can cancel both of those out. And then y to the 9th, well, you can write out all of those y's, but I know that's time consuming and it takes up a lot of room. So there's 9 of them up here. There's 13 of them down here. You can just picture that 9 of these y's down here would cancel out with these y's up here, right? And then there's still 4 more down here that weren't canceled out with the ones on the top. So you have 3 x's multiplied together on top and 4 of them on the bottom. So with the 7 on top, you still have x cubed. On the 4 with the 4 on the bottom, you have y to the 4th. This is our final answer. We can't simplify any further than that. So that's it. Last one, negative 8. Let's see if this is going to let me write. So negative 8 times that quantity raised to the 0 power. Anything to the 0 power is 1. So really what we have here is just negative 8 times 1. Or in other words, you just have negative 8. So your final answer on 21 is just negative